All right, this is our grade 9 Reachback, grade 9S Reachback. This is the Spicy Curry edition. Um, for today's Reachback, we're going to do things just a little bit differently. We're going to do a Reachback of 12 questions. I hope you guys are all staying safe and washing your hands and staying away from large gatherings of any kind, and hopefully we'll see you back in school in no time. But until then, if you want to print a copy of today's questions, you can go to tinyurl.com/G9S for grade 9S, Reachback 2. If you type that exactly as it's written there into your web browser, it'll take you to a PDF printed copy of the 12 questions we're going to do today. If you have a printer, print it off. If you don't have a printer, don't worry about it. Just look at it. And if you don't want to even do that, what you can do is just watch this video and press pause, get an answer, and see if you were right. Any mistakes, take a post-it note or a highlighter or whatever you have, and make a note of what mistakes you made during that question, because when we do a reach back like this again, you can look at your question sheet before and you can see what you did wrong. So anytime you make a mistake in this particular video, make sure you copy down what it is you should have done and any notes you want to take about what it was you should have thought about, okay? So with that said, we're going to start here with question number 1 to start. -10 plus +2 plus +9. Now, before you go ahead and do this, let me give you some reminders. If you have negative numbers, you can think of that as being money you owe. And if you think about positive numbers, you can think about money you have. When you combine them, don't forget, if you have more debt than you do money, you're going to still owe money. And all those things that we talked about before. So go ahead and give this a try. Show all your work. And when you're done, press unpause, and I'll show you the results, show you the answer. Okay, so the first thing you should have done is -10 plus +2. So if you think about -10 plus +2, remember when we used the integer chips or the poker chips? We said 10 negatives, which would look like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 2 positives, which would be your solid or your red integer chips. If we had 10 negatives and 2 positives, 1 negative and 1 positive make a 0 pair. Do you remember that? And this one here would be a 0 pair as well. And what we'd be left with is -8. So when we think about -10 plus +2, it's a -8. Another way to think about that is if you owed $10 and you had $2, well, you could pay off $2 worth of the debt you have and you still have $8 worth of debt at the end. And we would combine that with +9. Now that we have this, we have a -8 plus a +9. If you wanted to model it, you could put 8 negatives, 1, 2, 3, 4, 5, 6, 7, 8, and 9 positives. The 8 negatives and the 8 positives would make 0 pairs, and you'd be left with a +1 as your final answer. So the answer to this question is +1. Another way to think about that, if you wanted to, is I owe $8 and I have $9. So if you owe $8 but have $9, you can pay off all of your debt and still have $1 left over. Okay? So the answer for that is +1. If you didn't get that right, make sure you copy down what you should have done, and make sure you use the integer chips if you have them. If not, you can draw them like I did to help you figure out the answers the next time you have a question like that. Question number 2 is a multiplication question. And before you start tackling this question, let me give you a reminder. There are multiplication and division sign rules, and they have to do with same signs versus different signs. What happens when you multiply same signs together, and what happens when you multiply different signs together. So go ahead and take your time and do that question. When you're ready, press unpause and see if you did it correctly. Okay, so those rules I was talking about before, when you are multiplying, or that's not the marker I wanted. When you are multiplying or dividing, if you are multiplying the same signs or dividing the same signs, like a positive times a positive, or a positive divided by a positive, or a negative times a negative, or a negative divided by a negative, in all of those cases, when you are multiplying or dividing same signs, you will always end up with a positive answer. Remember that? And if you do the opposite, like a positive or a negative times a positive or a negative, etc., when the signs are different, you will always end up with a negative answer. Those are the sign rules that we talked about, and we used the modeling before to talk about those. But that's the thing you need to remember. If the signs are the same, you get a positive answer. If they're different, you get negative. So with that said, I'm going to ignore my signs. I'm just going to do 10 times 2, and 10 times 2 we know is 20. And then what I'm going to do is go back and look at my signs. Now, this 10 doesn't have a sign here. But we said that if a sign, if like the number 10, is that a positive 10 or a negative 10? We know it's a positive 10, but it's not written. So if you wanted to put a positive, you could. And then we have a positive times a negative, which are different signs, which means my answer, because they're different, is going to be negative. So the answer is negative 20. Question 3, we have subtraction. And before you do this, remember that I have never subtracted a question for integers in my life. I always change it to something and do something. So go ahead and try that and see if you can get the right answer. Press pause here. Okay. Remember I said I used to do something I've never subtracted. Remember what I always do is I keep the first integer, I change my subtraction to addition, and whatever this integer is here, I add its opposite. So the opposite is positive 2. So instead of doing 10 take away negative 2, I'm actually going to do 10 plus the opposite, which is positive 2. And when I change it to 10 plus 2, I think everybody can do this one because 10 plus 2 is really easy. The answer is 12, or if you wanted to, you can put down positive 12. Your next question is division of integers. And remember, when we did the multiplication of integers back in question 2, we said the same sign rules have to be applied. If you have the same signs, you do something. If you have different signs, you do something. So that rule applies for division as well. Go ahead and try that and see how well you do. All right, so the first thing I'm going to do is I'm going to do 12 divided by 2. And $12 divided between two people is $6 each. So 12 divided by 2 is 6. The next thing I'm going to do is I'm going to check out what my signs are. And if I look at my signs here, I'm going to grab my highlighter. This is a negative divided by a negative. Those are the same signs. And when you multiply or divide, if you're dividing the same signs, you will always end up with a positive final answer. So the quotient, or the answer to this division, is positive 6. Question 5, we have now breaking into fractions. We have 1/2 plus 1/8. And when you are adding or subtracting fractions, remember what we used to do. We said that when you add or subtract fractions, you need to have what we call a common denominator. So make sure you use common denominators and make sure you get the right answer. So go ahead and try this. And if you forget totally, don't press pause and just listen. But if you can do it, press pause, give it a try, and see if you got the right answer. Okay, so for 1/2 plus 1/8, we need to figure out what is a common denominator that I can use that 2 and 8 have. And the way we learn to do that is we learn to figure out what are the multiples of each of these numbers. So I've done the first 7 multiples of 2. And if I do the same thing for 8, do all the multiples of 8, what we're going to look here for is, do they share any common multiples? And if we look closely, we'll realize that the first multiple they share is 8. Now what that means is we can use 8 as our common denominator for these two fractions, okay? So once you have 8, you can erase this stuff because you don't need it anymore. Our next stop is to then make what we called equivalent fractions. So 1/8 doesn't have to be changed into anything. It's already 1/8, so we're going to keep it as 1/8. But the second fraction, this 1/2, I have to make it into an equivalent fraction out of 8. So I'm going to say 1/2 is equal to what over 8? So here I have to figure out, well, how do I get 2 to be 8? Remember we said you had to multiply or divide by a common number. In this case, 2 is multiplied by 4 to get 8. So in order to keep it equal, I have to do the same multiplication to the top number, or the numerator. That leaves me with an equivalent fraction of 4/8. And that makes sense. If you had 1 part out of 2 or 4 parts out of 8, you have half of the item. So 1/2 and 4/8 are what we call equivalent fractions. So once we've written it down like this, our next step is pretty simple. If I have 4/8 and I add it to 1/8, how many 8s do I have in total? Well, you take your numerators and add them. And if you had 4/8 of something and 1 more 8, you would have in total 5/8. And your final answer for question 5 is 5/8. Again, if you got that wrong, please make sure you note all those things, even the things I erased. Go back and press pause so you have a copy of what it was you did. And the next time we do it, you can hopefully do it right the second time. Question 6, this time I'm going to leave all the work on the screen here. I'm not going to erase anything so you can have it. So our first step is to find the multiples of 5 and 15. So make sure you press pause if you want to do it. Oh, I'm going too fast. And press unpause when you're ready, and I'll give you the answer. Okay, so the multiples of 5, if I keep going, I can go as far as I want. I'm going to stop there and see if that's far enough. I'll go 30 as well. So 5, 10, 15, 20, those are all multiples of 5. And 15 are 15 and 30 and 45 and 60, etc. So what I'm going to do here is I'm going to realize that the first multiple that they share is 15. But another multiple they share is 30. We could do 30 as well. They share multiples, different multiples. So what that means is we could use either 15 as a common denominator, or if we wanted to, we could use 30. But what we said before, it's always easiest to use the lowest number or the lowest common multiple because that makes your fractions easier to work with. So what I'm going to do is I'm going to rewrite this question. Instead of doing 2/5 plus 1/15, I'm going to do something over 15 plus something over 15. Now, just like the last question, 1/15 is going to stay 1/15 because it's already as it was. And our next part is to figure out 2/5, that first fraction, is equal to how many 15ths? Well, I'm going to take my multiplier and say, what did I multiply 5 by to get 15? I multiplied it by 3. So if I multiply the other one by 3, I'm going to get 6/15. So what we can say is that 2/5 is the same value as 6/15. They are equivalent fractions. Once we have that, if I have 6/15 and I add to it one more 15th, how many 15ths do I have in total? I would have 7/15. So your final answer for that is 7/15. Question 7, go ahead and try it. This time, remember, it's subtraction, not addition, so make sure you don't add them together, but rather subtract. All right, first thing is easy. Find your multiples of 3 and 6 to find your common denominator. Well, that was easy. I found it right away. Look at that. The first multiple they share is 6. So what I'm going to do here is I'm going to rewrite this as 2 fractions out of 6. The good news is the first fraction, 5/6, is not going to change. But 1/3 has to be made into a fraction that has 6 as the denominator. Okay? What do I multiply 3 by to get 6? The answer is 2. So therefore, 2/6 is equivalent to, or is equal to, 1/3. Now that I have this, if I have 5/6 and I take away 2/6, 5/6 take away 2/6 is 3/6 as a final answer. Now remember, what do you have to look for in your final answer? You have to ask yourself, is this in lowest terms? And the answer is no. Because 3 out of 6, what number can I divide 3 and 6 by? You can divide both by the number 3, and you end up with 1/2 as lowest terms. Lowest terms. Now, if you kept it as 3/6, that's okay as well. That's just not lowest terms. But if you were able to see it as being 1/2 in lowest terms, bravo to you. And our last fraction question is the tough one. It's 1.5 plus 2/5. There are 2 ways you can do this. It depends on which way you want to use. You can either add the whole numbers together and add the fractional parts together, or if you want, you can change the fraction part to a mixed fraction. You go ahead and try that, see if you can do it, and I'll show you the answer in just a second. Okay, so there are 2 methods that I'm going to show you both. Method 1 is to think about 1 plus 1/2. So 1.5 is really the same thing as 1 plus 1/2 plus 2/5. Remember when we did this? We had the whole numbers, and then we said, you know what? I'm just going to bring this 1 down here, and I'm not going to worry about it. I'm going to add it to the whole thing later. Right now, I'm going to think about what is 1/2. Oops. What is 1/2 plus 2/5? Now here, if I wanted to find the multiples of 2 and 5, 2, 4, 6, 8, 10, 12, 14, and 5, 10, 15, 20. The first multiple they share, I'm going to grab my highlighter here, is the number 10. So because 2 and 5 share a multiple of 10, that is the denominator we're going to use in our 2 fractions. Okay? So our next step, once we have our common denominator figured out, is figure out what is our equivalent fractions. So 1/2 is equal to how many tenths? You have to ask yourself the question, what did I multiply 2 by? I multiplied it by 5. and I end up with 5/10 as an equivalent fraction to 1/2. Now, if I'm going too fast, make sure you use the pause button to your advantage, because sometimes it's easier just to press pause and then unpause instead of trying to keep up with my handwriting. The next part is 2/5. That's our next fraction. That's equal to how many tenths? So the question you have to ask yourself is, what did I multiply 5 by to get 10? And the answer, of course, is 2. So because I multiplied the bottom number by 2, or the denominator by 2, I have to multiply the top number, or the numerator, and I end up with 4/10. Okay? And 5/10 plus 4/10, if I added those together, is going to be 9/10. So this part of my question equals 9/10. If I add it to the 1 that's down here, my final answer becomes 1 and 9/10, and that's your answer, 1 and 9/10. I know that's a lot of work, and this is one of the harder ones we would have done in class, but hopefully you were able to follow the idea of what it was we were doing. And there was a different method we used, and I'll show you that right now. So if you haven't copied this down, press pause and copy it down, and I'll erase it right now. The second method we learned was that you can change 1/2 into what's called an improper fraction, right? Because 1/2 is called, this is called a mixed fraction because it has a whole number and it has a fraction to it. Well, we can change it to an improper fraction. And if we think about what 1/2 looks like, well, there's 1 and there's a half. So 1/2, if I ask the question, how many halves is 1/2? The answer would be there's 1/2 there, there's 2 halves there, there's 3 halves altogether in 1/2. So we say 3/2, or 3 halves, is the same as 1/2. So once we have it written down like that, I'll erase this part over here. I'll keep it there. I could say 3 halves plus 2/5. That's going to be the same question. These two are the same question. The only difference is 1/2 is changed to an improper fraction of 3 halves. Oops. So once we have that written down, we need our common denominator. We already figured it out in the last part. 10 was going to be the common denominator. I multiplied this by 5 to get 10, so I multiply this by 5 to get 15. So 3/2 is equivalent to 15/10. And if I think about this, 5 times 2 is 10, and 2 times 2 is 4. So 4/10 is equivalent to, oops, daisy, 2/5. Those are equivalent fractions. And now that we have that, if I have 15/10 plus 4/10, oopsie daisy, I get 15 plus 4/10, which is going to be 19/10 as a final answer. But we all know that 19/10 is an improper fraction. So if I think about what 10/10 is, 10/10 is 1, and 9/10 would be left over. If you only had this, that's fine. That's fine to keep it as 19/10 because that's the right answer. But if you put it back to mixed fraction, if you're familiar with that, that's good as well. And since we're not doing it face to face, I'm okay if you leave it as improper. Question 9, we start getting into our basic algebra questions. Go ahead and press pause. Remember, opposite operation, you want to do the opposite to one side to get the other answer, to get the final answer. Okay, so if you look at this question, on this side of the equation, if I was to think of it as a drawing, I have x and I have minus 5 equals positive 10. Remember this when we drew it out? So I said, if I wanted to solve this question, what would I do to isolate the variable? Well, what I want to do is I want to get x by itself. If I can get x by itself, this is x, then whatever's on this side is going to be the value of x, right? So I'll erase that here. So how do I do this? What am I going to do? Well, the first step is to get rid of this part here, which is this part here. If I say, well, what is that part called? It's called the constant. Remember that? We called it the constant. So if I add 5 to this side, and I add 5 to this side, then it should maintain equality. But adding 5 to these negatives make a 0 pair, and I'm left with just x. And adding 5 over here leaves you with, well, I'm too lazy. I was going to say 15 of these. And therefore, your answer is x equals 15, or x equals 15. That's how we would do it if we drew it. So if you want to take a second and just draw that, that's great. Now, if you didn't draw it, you could do the same thing using numbers. The only difference is here, I'm going to add 5 to this, and I'm going to add 5 to this side. Remember, we put a line through it to show that's a zero pair. I'm left with x equals, well, what is 10 plus 5? 10 plus 5 is 15. That's a much easier way to get the same answer of 15 without having to draw it. But the drawing is important because it makes sure you understand what it is you're doing. In your next question, it's almost the exact same thing, except if I think about the drawing, it's an x plus a 5. Those are positive 5, not empty ones, and it equals a 10. So if I wanted to get rid of this, what would I have to do? I'd have to put 5 negatives here. And over here, I'd have to put 5 negatives to keep it balanced. That would make a zero pair, leaving me with x. And over here, that's a 0, that's a 0, that's a 0, that's a 0, that's a 0. I'd be left with 5. And my answer would be x is equal to 5. That's if I drew it out. Remember how we did that when we drew it? Yeah. If you didn't draw it, what would it look like? Well, instead of adding 5 to both sides, like I did in the last question, I'm going to subtract 5 from both sides. A positive 5 and a negative 5 make 0. I'm left with just x. And a positive 10 and a negative 5 make a positive 5. So my final answer is going to be x is equal to 5. And your second last question says 5x equals 10. Now remember, when you do this, this means 5 multiplied by x equals 10. Go ahead and try that out. Okay, let's try drawing it first. See how well you do if you drew it. So there's 1, 2, 3, 4, 5 x's is equal to 10. So if I was to draw it, 5x is equal to positive 10. All right, 5x is equal to positive 10. Oh, heavens. Now that we have it drawn, I don't want to know what 5x is equal to. I want to know what 1x. So what I'm going to do is I'm going to take those 5x's, I'm going to divide them onto 5 different scales. So if I took these 5x's and divided them into 5 scales, and took all of these and divided them into the 5 scales, I would have something that looks like this. So these 5x's were divided onto the scales. Oh, those other ones were divided there. And each of these scales, therefore says x is equal to 2. So your answer is x is equal to 2. That's if you drew it out. Okay. Now probably most of you didn't draw it. So if you want to draw that, go ahead. You press pause and draw it. And if you didn't, that's okay, because what we could do here, since this says 5 multiplied by x, the reason why we don't use a multiplication sign is that a multiplication sign and an x look an awful lot alike. So instead we use what's called the coefficient relationship. And even though that means it, what I'm going to do here is I'm going to divide both sides by 5. Just like when I divide it into 5 scales. And 5x divided by 5 is 1x. And 10 divided by 5 is 2. So I end up with the same answer, except here I did 10 divided by 5 is 2, and 5x divided by 5 is x. I end up with x equals 2, the same answer. I know this is pretty tough, so this is your last question, question 12. It took you a lot longer than you thought it would, but hopefully you're not all given up by now, but you're still working at it. So the last question says x divided by 5 is equal to 10. Go ahead and try and work it out, see what you do, and see if you get the right answer. Okay. So remember when we drew this number, x divided by 5, or we said it was a fifth of x. So if I think of x divided into 5 parts, this is what it would look like, okay, is equal to 10. So when I have a fifth of x is equal to 10, remember our goal is not to know what x divided by 5 is, but rather what 1 full x is. And the question is, how many of these do I need to make one of these? Okay? And the answer is you need 5 of them. So what I need to do is I need to multiply this side by 5. Okay? And these 5 parts put together would equal 1 full x. And remember, if it's a scale and I multiplied the weight of this side by 5, then in order to keep it balanced, I also have to multiply this side by 5. Okay? So right now we have 10 of them over here. And if I multiplied it by 5, I would have to have those 10, but not one of them. I'd have to have 5 groups of 10. That's 1, 2, 3, 4, 5. 5 groups of those. So there's one group, there's 2 groups, there's 3 groups, there's 4 groups, and there's 5 groups of what was on there. So here is 5 times bigger than it was. Oopsie daisy. What happened there? And here is 5 times bigger, and I end up with the answer of x is equal to 50. All right? That's if you drew it. That's a lot of drawing, so probably nobody would want to draw that, right? Nobody would want to draw that. So instead of drawing that, here's what we're going to do. The opposite of dividing by 5, I think we talked about it before, is multiplying by 5. So what I'm going to do here, instead of dividing by 5, the opposite is multiplying. So I'm going to go multiply that by 5 and multiply that by 5. Those are opposite. It leaves me with x. And 10 multiplied by 5 is 50. And I end up with the same answer I did with drawing it, except it says x equals 50. Now, I know this was a lot of work. This was 26 minutes long, and it was a lot longer than I wanted it to be. Next week's formative quiz will not be anywhere near as long. Friday, what we're going to do is I have another a fun activity designed for you guys, so tune in Friday. It'll be a lot easier. And then Monday, we'll get back to the reviewing of algebra, integers, and fractions. And hopefully by the time we get back to school in May, you guys are still masters of those 3 concepts. So stay safe. I miss you guys a ton, and can't wait to see you guys again.